So in this video, I'll discuss about the properties and reactions of alkynes. So alkynes are hydrocarbons that contain the carbon-carbon triple bond. Okay? So sa triple bond na yan, meron tayong isang sigma bond and dalawang pi bonds. So yung dalawang pi bonds na yan, yung usually nagpa-participate sa mga chemical reactions. So how do you prepare alkynes? So in this slide, makikita nyo na nagkaroon ako ng preparation from alkanes. Okay? So for step 1, free radical halogenation ng alkanes para mag-produce ng alkyl halides. And then, I subjected the alkyl halide through elimination reactions. So, sa elimination reaction na to, okay, nag-produce tayo ng propene. So, this alkene was then subjected to dihalogenation without light. Kasi hindi na kailangan ng light kapag ka alkene na. So, this dihalogenation product was subjected to subsequent elimination reactions hanggang mawala lahat ng halide. So, elimination reaction number 1, nag-produce tayo ng alkene na may bromide. Okay? So, this is an alkenyl bromide. Alkenyl kapag ka alkene. Okay? Kapag ka naman alkane, alkyl lang. Okay? So, from this bromide or alkyl halide na alkene, okay, nilagyan tayo ng another elimination product para mag-form na tayo ng ating propine. Okay? This is propine. So, hindi na natin kailangan nilagyan ng 1 propine or 2 propine kasi wala namang 1 propine and 2 propine. The triple bond reaches 1 and 2. Okay? Yung carbon 1 and 2 nila. So, wala na masyadong variations dyan. Actually, wala namang ibang klase ng propine. Okay? So, that is for the preparation of alkynes. So, alkynes can be classified depende dun sa position ng ating triple bond with respect to the parent chain. So, kapag yung triple bond ay nasa dulo na ng chain, ang tawag doon ay terminal alkyne. Otherwise, kung nandun siya sa mga gitna, okay, basta wala siya sa dulo, ang tawag doon ay internal alkyne. Okay? So, terminal alkynes are special because sa dulo niya, meron tayong sp hybridized na C. Okay? sp hybridized yan. Tapos may nakakabit sa kanyang hydrogen. And that hydrogen is acidic. Okay? So, the acidity of that hydrogen is due to the high S character of this particular carbon. So, since mataas yung S character niya, mas spherical yung ating sp hybridized carbon. So, dun kasi kumakabit yung hydrogen through sigma bond. Mas mababa yung overlap niya compared kapag mas matataas yung P character. So, ano yung mga mas matataas na P character? Yung sp2 tsaka sp3. Kaya yung mga alkanes, stable yung kanilang carbon-hydrogen bond kasi mataas ang overlap nun. Kahit sila yung pinakamahabang bond. Mas mahaba kasi ang P kaysa sa S. Kaya longest bond ang sp3. It's 75% P, 25% S lang. Sa sp2, mas maikli ang sp2 kasi 33% S. Okay? So, ano itsura ng S? Diba? Ano siya? Spherical. Tapos yung P mo ay lobes. Okay? Parang dumbbells. So, kapag pinagsama mo yan, tapos maintain mo yung S at 33%, P at 66.6%, sp2 yung orbital mo. Mas maikli siya kaysa sa sp3. Pinaka-maikli si sp kasi 50% yung S character niya. So, siya yung pinakabilog dyan sa tatlong hybrid structures na yan or hybrid orbitals. Okay? Pinakamababa rin yung overlap niya sa hydrogen. Kaya madaling na-abstract si hydrogen dyan. Okay? So, since acidic siya, madali siyang i-abstract. Nagpo-form tayo ng acetylide anion. This acetylide anion is very useful for carbon-carbon bond building processes. So, kung gusto mo mag-form ng carbon-carbon bonds, pwede tayo mag-start with the acetylide anion. Okay? Internal alkynes naman, meron tayong open chain internal alkynes, meron din tayong cyclic. So, the smallest cyclic alkyne known to man is the cyclooctane. So, that's actually the most stable alkyne. Kasi rings that are less than 8 for alkynes are already unstable. Okay? So, kapag ka may triple bond ka tapos cycloheptine siya, hindi na siya kasing stable ng cyclooctane. Mahirap na siyang i-synthesize. Okay? So now let's proceed to reactions of alkynes. So unahin na natin yung addition reaction. Kasi alkynes react like alkenes. Okay? Ang pinagkaiba lang nila, alkynes have 2 pi bonds. So ibig sabihin, per mole ng alkyne, kailangan natin ng 2 moles ng addition reagents para magkaroon tayo ng ganitong product or mawala lahat ng pi bonds mo, ma-convert lahat sa sigma bonds. Okay? So since ganyan yung product, ano yung naging mechanism? So, sa unang add mo ng HBr, Markovnikov addition siya. So, nasa less substituted carbon yung H mo at nasa more substituted carbon yung Br. Okay? So, ganyan yung ating addition reaction. After addition of another HBr, magpo-produce ka ng ganitong product because of the Markovnikov's rule. Yung dalawang Br mo dyan ay nasa more substituted carbon. Kahit dito sa internal alkyne na ito. Kapag nag-add ka ng 2HBr, okay, yung Br mo yung nasa more substituted carbon and yung hydrogens mo yung nasa less substituted carbon. Okay? So, paano naman kapag anti-Markovnikov? Baliktad. So, nandito yung iyong Br sa less substituted carbon kasi yung bromine radical, again, yung unang nag-a-add sa reaction. Okay? Yung hydrogen, yung huling na-add. So, ang napoform mo pa rin talaga dito ay more substituted carbon radical. Pero apparently, it's an anti-Markovnikov product kasi nasa less substituted carbons yung iyong bromines. Okay? Ganon din sa internal alkyne na nandito. So, pag nag-add ka nito, okay, with peroxide, again, peroxide is the one that promotes free radical mechanism, kaya nagkakaroon ka ng peroxide effect na tinatawag. Okay? So, nandito yung iyong Br sa less substituted carbon at nandito yung hydrogens mo sa more substituted carbons. Okay? So, now let's proceed to oxidative cleavage reactions of alkynes. So, ano muna yung oxidative cleavage? Ang ibig sabihin nito, you are doing oxidation while breaking bonds or cutting bonds. Okay? So, ang ginagawa natin dito, generally, kinakat natin yung bond na to, tapos nagpo-produce tayo ng more oxidized products. Okay? So, in this case, we have ozonolysis and the strong oxidation, yung ating hot acidic KMnO4. So, ozonolysis, we put first ozone and then we treat this with zinc in acidic medium. Okay? So, ang napoproduce pag terminal alkyne, meaning yung sp carbon na to, merong exchangeable hydrogen. This carbon becomes CO2. Okay? So, lagyan natin ng A. So, this is A. Tapos, B, okay, becomes a carboxylic acid kasi siya yung nasa inner chain. Okay? So, this is B. Since ito yung methyl group na yan. Okay? Kapag internal alkyne naman, this one, A, becomes this one. Yung sp carbon na to, naging carboxyl carbon. Okay? Ito yung sp carbon na yan. Tapos, ito naman, this is B. This becomes B. And this is the sp carbon na to. Okay? So, ganyan lang ang nangyayari. Yung triple bond nagiging double bond O tsaka OH kapag ka ozonolysis. Okay? However, pareho lang siya nung strong oxidation. Kapag naglagay ka ng hot acidic KMnO4 sa same compound, pareho lang yung nagiging product. Ganon din sa internal alkyne. So, yung oxidative cleavage reaction through hot acidic KMnO4, pareho lang siya kapag ozonolysis. So, same yung products nila, okay? Hindi tulad sa alkenes. Kasi kapag ka ozonolysis ng alkenes, nagpo-produce ka ng carbonyl compounds, aldehydes and ketones ang nagpo-produce mo. Pag strong oxidation ng alkenes, tsaka ka lang nagpo-produce ng carboxylic acids and CO2. In this case, kapag alkynes, pareho siya. Okay? So now let's proceed to hydrogenation reactions of alkynes. So, meron tayong dalawang klase ng hydrogenation dito. Yung total hydrogenation or yung complete hydrogenation nyo, wherein all your pi bonds become sigma bonds, tapos nauubos yung mga sp2 and sp hybridized carbon mo. Lahat sila sp3 na. Okay? Tapos, meron naman tayong partial or incomplete hydrogenation. So, yung alkynes mo nagiging alkenes. Yung sp nagiging sp2. Okay? So, sa complete hydrogenation, ang kailangan lang natin ay hydrogen. Okay? Tapos, meron tayong heterogeneous catalyst, either palladium or nickel na nandun sa solution. Solid yan na nasa solution. So, complete yung hydrogenation mo kapag yan yung reagent. However, kapag ang reagent mo ay yung tinatawag nating Lindlar's catalyst, okay? So, Lindlar's catalyst is a weakened version of your palladium catalyst. Nagkakaroon ka ng partial hydrogenation. Siyempre, i-control mo din yung amount ng hydrogen para hindi ka magkaroon ng side product na completely hydrogenated. Okay? So, hydrogenation reactions are syn addition reactions. Okay? Even dito sa complete hydrogenation. Okay? So, we can also classify hydrogenation reactions depende dun sa stereochemistry ng addition ng hydrogen. So, for example, meron tayong alkyne, okay? Kapag nilagyan mo siya ng lithium or sodium submerged in ammonia, okay? Nagkakaroon tayo ng anti-addition ng hydrogen, okay? Tapos, kapag ka naman hydrogen in Lindlar's catalyst, we know that to be a syn addition mechanism, okay? So, yung anti and syn addition, depende yan sa ating target na product, kung ano yung gusto nating ma-produce dun sa reaction. Pwede tayong mag-produce ng E or Z isomer, depende dun sa ilalagay nating reagent. Kung ito ba, or yung Lindlar's catalyst, okay, with hydrogen. Okay? So, we also have acid-base reactions for terminal alkynes only. So, Nangyayari lang yan sa terminal alkyne, hindi siya nangyayari kapag ka internal alkyne. Because this hydrogen here is acidic. Wala tayong hydrogens na acidic sa purely hydrocarbon na alkyne. Lalo na pag internal. Okay? So, pag internal alkyne, no reaction. Terminal alkyne, meron siyang production ng sodium acetylide. Okay? So, proceed naman tayo sa mild oxidation. So, kapag mild oxidation, walang involved na cleavage. Okay? Hindi natin nakakat yung triple bond. So, anong reagent yon? Yung Bayer's reagent. Okay? So, this is the Bayer's reagent. So, kapag ka-alkene, if you remember, ang napoproduce ng Bayer's reagent ay yung 1,2-diol or yung vicinal diol. So, in this case, kapag ka-terminal alkyne, ang napoproduce niya ay alpha-oxo acid. So, alpha-oxo acid. Yung inyong oxo or yung carbonyl group ay nasa carbon number 2 ng carboxylic acid product. Okay? So, magiging carboxylic acid to. Pero ang intermediate niya ay alpha-oxo aldehyde. Okay? This aldehyde will be oxidized further to form the alpha-oxo acid plus of course the brown MnO2 solid. Okay? Kapag internal alkyne naman, wala siyang exchangeable hydrogen tulad nito. So, kapag internal alkyne, ganyan lang. Ang napoproduce naman niya ay alpha diketones. So, ang ibig sabihin ng alpha diketones, adjacent yung carbonyl groups. Siyempre, yung carbonyl carbons, sila yung sp, hybridized carbons, dun sa alkyne yung substrate. Okay? So now let's proceed to oxymercuration, demercuration reaction. So this particular reaction is just simple. Nag-a-add ka lang ng hydroxyl group sa more substituted carbon ng either ng double bond or ng triple bond. So for example, meron tayong alkene. Okay? Kapag ginawa mo tong reaction na to, okay? So ang una mong gagawin, mercuric sulfate muna in water, then mag-a-add ka ng acid which is H2SO4. Okay? So pag ginawa mo yan, Markovnikov addition lang. Nagkakaroon ka ng more substituted na alcohol. Okay? Ganyan kapag ka-alkenes. Paano kapag ka-alkynes? So, pag alkynes, same pa rin yung mechanism niya. Ang napoproduce mo lang ay hydroxyl group sa more substituted carbon, yes, pero meron ka pang double bond. So, ang tawag dito ay enol. However, this enol is not very stable. Kaya ang nangyayari sa kanya, nagkakaroon siya ng mechanism called the tautomerization. Okay? So, during the tautomerization reaction, nagre-rearrange yung compound mo para mag-form siya ng mas stable na form. So, paano ito nagtatautomerize? This double bond will combine here. So, mapupunta siya dito. Okay? Tapos, syempre, magkakaroon ka ng carbocation intermediate doon. So, yung OH bond na nandito, mapupunta siya doon. Kaya magkakaroon ka ng ketone. Double bond O. Okay? Yung iyong oxygen mo mag-double bond dito sa carbon na to. So, this is the keto-enol tautomerization. Okay? So, this is the keto tautomer. This is the enol tautomer. Okay? Tautomers ang tawag dyan. Okay? So, ang nangyayari lang dyan, nagkakaroon ka ng more substituted na ketone. Kasi may more substituted ka na source, which is the more substituted enol. Ganun din ang nangyayari sa internal alkynes. Okay? So, now we have some sample problems. Ang gagawin lang natin, ipe-predict natin yung mga products ng reactions per step. So, for number 1, we have this internal alkyne. So, nag-add daw ng sodium with ammonia. We know that this is a partial hydrogenation reaction na anti yung ating product. Okay? So, anti na alkene. Ganyan yung magiging product niya. Okay? So, nandito yung methyl group, therefore, tapos nandito yung propyl group. Okay? So, that is the product for the first step. Tapos, i-ozonolysis daw natin siya. Okay? So, ang mangyayari, magkakaroon tayo ng product or carbonyl compound from this one. So, this is the carbonyl compound from the first part. Tapos, meron tayong carbonyl compound again from this second part. So, yun yan. Okay? So, plus. Okay? So, for number 2, we have a terminal alkyne. Okay? I-react daw natin ng Bayer's reagent. So, kapag terminal alkyne, i-react mo sa Bayer's reagent, magkakaroon tayo ng alpha keto acid. Okay? So, ang product natin, isusulat ko lang ulit yung skeletal structure. Pero this time, ibe-bend ko na siya. Okay? So, ito na yung ketone based on this carbon. Okay? Tapos, yung carboxylic acid from this. Okay? So, yan na yung ating product for number 2. So, next, we have number 3. So, H2 with Lindlar's catalyst, magkakaroon tayo ng syn addition na partially hydrogenated na product. So, isusulat muna natin yung alkene, tapos syn. Okay? So, nandito yung ating cyclohexane or cyclopentane pala. Okay, so I'll just erase this one. Ayan. So that's the first product for this step. Tapos, this is a hydroxylation reaction. Naglalagay tayo ng hydroxyl group pero sa less substituted carbon. This is an anti-Markovnikov addition of the OH group. So, ang mangyayari, since anti-Markovnikov, okay, nandito ulit yung ating cyclopentane. Okay, nandito yung OH. So, nandito yung mga inad nating H. Pwede nyo hindi na ilagay yan. Pero i-emphasize ko lang dito sa problem. So, ayusin natin para maging cis or syn addition product siya. Okay. So, ilalagay ko lang yung mga hydrogens muna for emphasis. Tapos, nandito na yung OH. Okay. So, for number 4, we have another terminal alkyne. So, pareho lang siya ng number 3. Lalagyan daw natin ng lithium or sodium in ammonia. So, ito na naman ay isang case ng anti-addition na partial hydrogenation. So, ilalagay ko lang yung product. So, nandito yung isang hydrogen. Nandito yung isang hydrogen. So, anti siya. So, nandito yung ating cyclopentane. Okay? So, next is the addition of this reagent. So, this is oxymercuration demercuration. Pero this time, sa alkenes. Okay? So, ang nangyayari dito ay Markovnikov addition lang ng hydroxyl group. So, ang product nito ay Markovnikov na alcohol. So, ilalagay ko lang ulit yung H na naka-anti for emphasis. Tapos, nandito na yung OH. So, magkaiba yung magiging product sa 3 and 4 kasi yung number 3 ay anti-Markovnikov. Yung number 4 ay Markovnikov na alcohol. Okay? So, this is all for the discussion of alkynes. So, ang susunod kong video ay aromatic compounds na. Okay? So, see you next video.